The last speaker of the day, of the morning, is Vassilis Panagopoulos, sorry for the pronunciation, that we will talk about evaluation of smoking cessation treatment with the psychometric test and the EEG tomography. Please, Vassilis.
Thank you very much. It's nice to meet you all. I would like to thank you very much for being present for my presentation, for our presentation. My name is Vassilis Panagopoulos. I'm a psychiatrist. My subspecialty is addiction psychiatry. Today, I intend to explain why I decided to do my PhD in neuroscience under the supervision of Professor Ioannidis and Professor Kostopoulos and present to you my project. I would like to start by reviewing the current practice of psychiatry today. Basically, psychiatry is based on the DSM, the Diagnostic Statistical Manual of Mental Disorders, issued by the American Psychiatric Association. It provides a list of clinically observable or reported psychiatric symptoms that, when present in combination, produce a psychiatric diagnosis under specific criteria and conditions. These diagnostic criteria have been basically agreed upon by expert psychiatrists as the defining set of symptoms for its psychiatric illness and are updated regularly. Even with the most recent version of DSM, objective biology-based tests for most psychiatric illnesses, including schizophrenia, major depressive disorder, and bipolar disorder, are lacking. Basically, what are the implications of this lack of objective biologic tests in psychiatry? There are multiple. Firstly, there's no specific diagnostic test that can be run medically, or an objective biologic test to diagnose a psychiatric disorder. Many times also there is a problem where a patient meets criteria for multiple different psychiatric illnesses at the same time. So there's no diagnostic clarity. And the other issue is that it is impossible at this moment to predict which medication will work for which patient. Patients typically try a course of medication for several weeks to see whether this medication is effective or not. In other words, psychiatrists have no choice but to follow a cumbersome and time-consuming trial and error process to find the right medication. Also, research is much more difficult if there are no objective biologic tests. So it is believed, and we believe it also, that a more profound comprehension of the neurobiologic phenomena underlying the function of the brain and mental illness will eventually allow for the discovery of new molecular targets for medications, but also for the development of potentially diagnostic tests and predictive biomarkers that could even help in terms of predicting the response to treatment. And we feel that this will allow for overcoming the delays and the inefficiencies of the current psychiatric clinical care. And under this context, the so-called Research Domain Criteria Initiative of the National Institute of Mental Health in the US was started in 2009 with a goal of incorporating basic and clinical research in our understanding of mental illness, and it endeavors to lead to the development of a new classification of mental disorders based on dimensions of observable behavior as well as neurobiological measures. In this framework, our goal is to contribute in research related to the development of clinically meaningful biomarkers for psychiatric illness, either for diagnostic purposes or in assisting the clinical psychiatrist in selecting the right treatment for the right patient. Now, which psychiatric disorder did we select for our study? We selected nicotine use disorder or nicotine addiction. Why? Because smoking is very prevalent, because we have effective treatment interventions, which are often underutilized, And also, since I'm a psychiatrist with a subspecialty in addiction, I am able to provide those treatment interventions. Our goal is to learn more about the pathophysiology of the illness from a neuroscientific perspective, but also to establish whether the techniques developed by the laboratory of Professor Ioannidis and Kostopoulos could potentially predict treatment outcomes by conducting simple, affordable tests at baseline prior to receiving treatment. Therefore, we did a review of the literature, and the most pertinent article was this article by Franklin et al. And basically, in this study, it was shown with functional MRI that bilateral activation of the lateral orbitofrontal cortex was induced with treatment with varenicline, a medication that is FDA approved for smoking cessation, also available in Europe. During the resting state is when this was observed. Other changes in other brain areas were observed as well. We focused basically in our study in these areas that were found by Franklin and al. Now, except for the positive findings of this scientific team, also we thought that the lateral pedofrontal cortex is important because we know from the literature that it is implicated in addiction. That in fact, we know that the different anatomical parts appear to have distinct function in addiction when more specifically, when the reward value of the stimulus is low, the lateral aspect of the orbitofrontal cortex appears to be more active. When the reward value is high, the medial portion shows higher activation patterns. So it appears, and it has been hypothesized, that the lateral orbitofrontal cortex plays a role in incorporating information on the reward value of stimuli, which then also influences decision making. In the study of Franklin et al., as well as ours, the medication varenicline was used. Varenicline, briefly, is a partial agonist of the acetylcholine nicotinic receptors. It basically partially stimulates these receptors, and it is known to be reducing the reinforcing properties of nicotine. It makes nicotine less pleasurable, and it decreases the cravings for nicotine. So it was not surprising that it was shown with the study that I mentioned earlier that it activates the lateral orbitofrontal cortex. So it appears, and it has been hypothesized, I should say, that the lateral orbitofrontal cortex is likely involved in reassessing the reward value and reducing, most likely, the reward value of rewarding stimuli, also nicotine-associated stimuli. So in terms of recruitment, we recruited 5 regular smokers for the cases group. The inclusion criteria were basically that they're active smokers not receiving treatment at the current time. And for the control group, 6 healthy volunteers, 6 non-smoking healthy volunteers were selected. Exclusion criteria included that they had to not suffer from any psychiatric illness, nor could they be taking any medications. The emphasis here will be on the first set of the results of the smokers group mainly. Under this study, a full psychiatric evaluation was conducted by myself, and the routine smoking cessation treatment was administered also by myself. 3 sessions of EEG and psychometric data questionnaires were administered at 3 different time points at the beginning of treatment, meaning on the first session, before receiving any type of treatment, during the treatment with varenicline, and after treatment, with the duration was approximately 3 months for this. Here is a list of the psychometric questionnaires that we utilized just for your reference. In terms of EEG, it was held in a dedicated room with 19 active scalp electrodes. A sampling rate was 500 hertz. The electrodes were placed according to the 1020 system. The volunteers completed 3 different tasks during the EEG recording sessions: the eye state change task, the music listening task, and the text reading task. The first one, the eye state change task, is the one that will be the focus here. It basically involves 3 conditions: the eyes closed condition, during which the volunteer is instructed to keep their eyes closed; the eyes open condition, during which the volunteer is instructed to fixate at the green dot in the center of the screen; and the eyes fixate condition, during which 90 images are presented at different places of the screen, the images being either faces or smoking related images. Today we will focus on the results of the eyes closed condition, because after the initial run it follows the eyes fixate condition, so it is right after volunteers have been shown smoking related pictures. So the eyes closed condition is going to be the focus. Now we will proceed to present the psychometric questionnaire data. Obviously, one of the most important treatment parameters in a typical smoking cessation study is the number of cigarettes smoked per day. Most of our volunteers, as you can see, showed a significant reduction in smoking. The average reduction in the number of cigarettes was 68%. One volunteer quit completely. There was one volunteer, HPD 560, who did not show any change in daily cigarette use and whose data will be marked with a black sheep for reasons that will become obvious later, as we will see how they did during treatment. Next, the number of cigarettes was plotted at baseline and at treatment termination to evaluate the effect of treatment. The assumption according to which the number of cigarettes smoked per day would decrease with smoking cessation treatment was tested with a Wilcoxon signed rank test, and there was a trend towards statistical significance with a p-value of 0.06, excuse me, but statistical significance was not reached, likely due to the small sample of our treatment study. Here you can see the Eurocall test score, which illustrates one's own assessment of the overall health on the day of the measurement. Here you can see the analysis of the score difference between the first and the last session among the controls and the cases. The non-parametric Mann-Whitney-U-Wilcoxon rank sum test was run to compare the difference between the 2 groups, as seen below. The groups were found to differ in a statistically significant manner. Basically, what this result indicates is that the smokers, but not the controls, perceived themselves as healthier at the end of the study in comparison to the beginning of the study, as would be expected, as the smokers to a big extent overall reduced their smoking habit. Now here we wanted to evaluate the predictive value of the contemplation ladder score in relation to the relative decrease in daily cigarette use with a linear regression model. And we did find a positive, fairly linear association with a Pearson correlation of 0.972 between the contemplation ladder score and the daily cigarette use, as illustrated in the figure, and the p-value was 0.005. The next questionnaire is the Rosenberg self-esteem scale, which measures global self-esteem and self-confidence. It evaluates both positive and negative feelings and perceptions about the self. There was one obvious outlier in our group, which was the same volunteer, HPD 560, with a score less than half in comparison to all the other volunteers, both at baseline as well as at treatment termination, as clearly depicted in the figure. And you can see the black sheep is back. Our second hypothesis was that the self-esteem score at baseline is a predictor of successful smoking cessation treatment, in fact, with a positive correlation. This hypothesis was tested with a linear regression model, and based on the results of the statistical analysis, we did find a positive, fairly linear correlation with a Pearson correlation of 0.94 between the Rosenberg self-esteem score at baseline, meaning prior to receiving any treatment, and the daily cigarette use decrease achieved by the end of the study, as you can see here. And the Pearson correlation coefficient was 0.94 approximately. The last part of the psychometric data analysis consists in the network graph analysis, utilizing the leading eigenvector algorithm for the cases group of psychometric data for 5 variables as follows. Basically, we used the questionnaires that we felt had the most interesting results, as well as the daily nicotine use. And in this network analysis, we can see that there are 2 groups, the yellow and the red group. HPD 560, the black sheep volunteer, let's say, is clearly separated from the rest of the group. This volunteer has the least number of connections with other nodes and the lowest eigenvalue centrality score. This was the single volunteer who was not able to reduce smoking, as we saw earlier. During the baseline session only of the study, 2 more volunteers, 561 and 562, were in closer connection with the aforementioned outlier and belonging to the yellow team, but during treatment, they drifted away from the yellow team and switched to the red team, as you can see in the graph. Next, I would like to proceed with the neurophysiology part of the study. In the current study, we used the technique that has been developed by the current lab of Professor Ioannidis to solve the electromagnetic inverse problem. This technique, electric field tomography, is the adaptation of magnetic field tomography to EEG data. Activation curves are extracted for selected regions of interest from the single trial data, producing real-time electric field tomography estimates of brain activity with no a priori assumptions. The electric field tomography results are stored at grid points spanning the entire brain. The time series at each grid point are then Fourier transformed, yielding the spectral density of each voxel. And here we will focus on the spectra for voxels within the regions of interest identified by Franklin et al. Here we see the tomographic solution for the lateral orbitofrontal cortex for one of the smokers during the eyes closed condition. The volunteer was receiving treatment with varenicline during experiment 2, but not during experiment 1. The mean is illustrated as a solid line. The standard deviation is illustrated as a dashed line. And here we see in the case of this volunteer that there is a higher peak at approximately 10 Hertz, which is consistent with the results that were reported by Franklin et al., where varenicline induced the activation of this brain area. And next we proceed to see the tomographic solution for the lateral orbitofrontal cortex for the next smoker volunteer under treatment with varenicline. In this case, we see a higher peak observed in the modulus by frequency value at approximately 10 Hertz during experiment 1 instead of experiment 2. which is the opposite of what we would have expected based on the previous results. However, we do see a higher degree of brain activation for experiment 2 above 30 Hertz, as the arrows indicate. In the case of the next volunteer, a higher brain activation is observed for experiment 2 for the majority of the frequencies, as expected based on the aforementioned study. These results appear to be confirming our original hypothesis. Now, below follows the principal component analysis of the 3 regions of interest of the lateral or pedofrontal cortex combined based on the results of Franklin. Namely, we named them ROI 30, 31, and 32. This is, we included only the alpha bands from 7.6 to 13 Hertz. And we conducted this under the eyes closed condition, utilizing data from the second session of the first 2 experiments at baseline prior to receiving any type of treatment and during treatment with varenicline. 2 cases, HPD.
Vassilis?
Yes.
5 minutes. We have only 5 minutes more. Sorry.
Yes. I'm
Yeah,
pretty much
sorry.
almost there.
Yeah.
Thank you very much for the reminder. So here we see that HPD 560 and 563 appear to separate from the rest of the cases, being the only ones that belong to the light blue group for both sessions. And just to remind you, here we see again HPD 560, the outlier from the previous data on the psychometric data and the smoking cessation data, but this volunteer also separated based on the electric field tomography data. No control volunteers were found to belong to the light blue group on both sessions based on these results. And in conclusion, this is just the beginning of the analysis. In our small sample, using the electric field tomographic analysis tools in a novel clinical situation, we experienced firsthand the difficulties of recruiting a clinical sample of smokers, given the laborious nature of our evaluations, which required significant commitment from the patients as well as us. To address this, we secured some funding from the local research institute. In the future, we hope to address this weakness in our study, namely the small clinical sample. And our future goals and aspirations also include expanding to different psychiatric illnesses, as well as different psychiatric treatments from this point of view. This explains why a psychiatrist is present in a mathematical conference like this. We feel that there is a need for collaboration among different fields on a wider scale to address these complex challenges of understanding brain function. We hope to stimulate interest in future studies of this nature, as well as collaborations. And the brain is the most complicated organ of the human body. We're only able to appreciate the tip of the tip of the tip. We hope that you found this presentation interesting, and I would like to thank you very much for your attention. And I would like to see if there are any questions.
Thanks a lot, Vassili. It was very interesting. Thanks.
Thank you.
So we see if is there some question. Okay, Sarah.
Hi, thank you for this very interesting talk. I'm a mathematician, but I agree with you that the interdisciplinarity is like the most exciting part of this work. I have 2 questions. One is more a little bit more in the interpretation of the results. I noticed it in the first picture in which you show which was the response of the subjects when you were showing if they stopped smoke or not. That the 2 persons that were the one that smoked the most, had the most extreme answers, because one stopped it while the other one just continue smoking as before. Did you have an intuition if this may, I mean, have any interpretation, or did you investigate if this has any interpretation, or do you feel that it's just by chance?
It's hard to know, really. You know, in part, you know, in smoking cessation studies, you know, it's some patients do well, some patients don't, and most smokers have to try several times in order to quit successfully, like more than 3 or 4. So it's not an uncommon result seeing someone who enrolls in such a study but doesn't reduce their smoking. But also, you know, it makes sense if someone says that I'm not very motivated to quit smoking. It is more likely that they will be the ones not doing well in terms of decreasing smoking. Also, if someone doesn't have a high self-esteem, it is also more likely that they will not succeed as well in this difficult challenge of quitting smoking.
Okay, but it was curious that the two that smoke like 25 cigarettes had this very extreme response, you know. It was curious to me, but yeah, it may be just by chance, as you said.
Yeah, a clear explanation we don't have.
Yeah,
The human soul is a mystery in general.
I agree. The other question is more mathematical. It regards the analysis of the EEG data. In particular, when you were observing that the high in the data in which you observed that the high frequency, there was a constant difference between the, let's say, the Varenicline, I hope I say it right, and the no Varenicline
Varenicline.
Varenicline, okay. So my question is, did you check that these differences, especially in the high frequency, are not, for example, due to noise? Do you have some tools to be sure that it's not the noise in the data that increase your data, your frequency, your spectrum, especially in the highest frequency? That is something that may happen with the EEG data.
I think that we did use some techniques. To be honest, I'm not the most technically savvy part of the team to answer that, but I think the Professor Ioannidis' camera showed up.
Yes, I see Andrea that show up.
Yes, we extensively look at the data and tried, you know, to clean it. Remember, this is looking from one part of the brain. The question is whether or not the technique can actually separate the sources, but this is not something which we cover here. We don't have this uniform McNaughton in all the areas, and we have the we see it in these cases here. Of course, in order to be able to do more, we have analysis at the level of the group that we're going to look at across all the areas. This is just the first one, and we decided to focus only on the areas that Franklin has identified, because if we try to do anything else, it would be impossible to just say anything sensible in the time we had available for this presentation. We are confident that this is not because of noise, but of course you have to do more data in order to actually put it in terms of statistics and everything else clearly. The most interesting part is that we have a psychiatrist who look at patients who look normally in an environment and trying to do this analysis. To get to answer your question convincingly, give us about another year.
Okay, perfect.
Thank you.
Thanks. And I have only one question, Vassilis. So did you also talk about features? So are you planning to do some decoding, to use some decoding algorithm to understand what is the best feature?
If we're going to try to find a way to predict which medication would work best. The idea is, you know, to hopefully expand the sample and having more data to see if by doing a simple EEG, one could predict if a medication would have if a patient would have a good response to a medication before trying the medication, ideally, or shortly after starting it, perhaps, which
So-
would be very important in psychiatry, you know, also for other illnesses, not just for smoking cessation.
Yes, you are at the beginning of the study, so since the sample size is little, so in the future, I hope you can have more subjects. So, okay.
Yeah, so do I.
Okay.
If I may
Thanks
add
a
just
lot.
if I may add just one point here, I think the amount of data collected from these 5 subjects is really huge. Okay, and plus of course the controls. Of course, Vassilis is a practicing psychiatrist, and obviously he's going to finish the PhD. So this is really open to a huge collaboration, and I'm looking forward to having something across Europe in which people with different techniques in all sorts of aspects, especially in decoding and identifying what the likely areas are like, you know, this is not something which it can be addressed in one PhD, especially in a small group like ours. But I think the point was to actually demonstrate that I was in big laboratories trying to do the big experiments with a lot of subjects in where you have a lot more difficulty in recruiting people who are looking like patients. So what we tried to prove is that, yes, we can do this analysis with real patients and real psychiatrists given the resources. So that's the main message coming out. And of course, your point of using different methods is spot on. We know we can do better than what we do right now, but that's not the point. The point is that we can do something which is scientifically valid and which can be expanded along the lines that many people have talked during this meeting, this wonderful meeting. Thank you.
Okay, thanks a lot, Andreas. Thanks again, Vassili.
Thank you very much for accepting our
No, it was very interesting. Thanks.